So we're on section 3.2, and if you watched the last video on section 3.1, we saw this method, the substitution method for linear equations. And if you are happy with the substitution method for solving simultaneous equations, the nice thing is now we do exactly the same thing. It gets harder because the equations that we're going to deal with in section 3.2 are nastier equations, but the idea is exactly the same. So x minus y equals 7, that's our equation number 1. And I'm taking the example, of course, straight from the book. Plus xy plus 2x equals 5, and that's equation number 2. So what was the first stage before? Well, let's have a look at it. The first stage before was take one of the equations and rearrange it to get x on its own or to get y on its own. Okay? Well, here, that's going to be the linear equation. So I'm going to rearrange. And again, it doesn't matter if I get x or y on its own. I'm going to go for x equals 7 plus y. Okay, and I'm going to call that equation number 3. So I've rearranged it, I've got x on its own. What did I do next? Well, I took my value for x and I substituted it into the other equation. So let's do that again. Sub 3 into 2. So if I take this, and every time I see an x in this equation, I'm going to replace it with 7 plus y. So here we go. Y squared plus, well, that's an x, and I'm changing that to 7 plus y, times by y. Plus 2 times, that's an x, let's change it to 7 plus y. That's equal to 5. Right, then what did I do next? Well, I've got an equation just in y and I solved it. Well, here we go, look, here's an equation with just y's in it. Now, okay, it's a quadratic, but we can solve quadratic equations. So 7y plus y squared plus 14 plus 2y equals 5. And I'm going to cheat slightly here because... Oh no, it looks like I can't cheat slightly here because I don't have this as an example, it's just one that we're talking about in the book. So I'll pause the video and solve that. You don't need to watch me solve a quadratic. So we've solved that equation here and we end up with y equals minus 3 over 2 and y equals minus 3. And I've solved that by factorising. The working out's there and I'm sure you can do that for yourself. If you can't, it's in chapter 2. We're solving quadratics in chapter 2. So by this point, we should be able to easily solve quadratics. Now I've got the y values. What I need now is the x values, right? So, and this is the same as before. Once I solved that equation and found the y value, I substituted it in and got the x value. So let's do the same thing. Now, I could use equation 1 or equation 2. Both of them tell me a link between x and y, but equation 1 is going to be a lot easier to deal with, isn't it? So sub into equation 1, and I get x minus the y value equals 7, and x minus the y value equals 7. So that is 7, well this is a plus 1.5, so take away 1.5 on this side, so x equals 5.5, and this is a plus 3 on this side, so take away 3, so x equals 4. If you're in an exam, we'd want to put those two together, so x equals 5.5, y equals minus 3 over 2, and x equals 4, y equals minus 3, because they come as pairs. I can't just write those 4 numbers in any old order. This pair and this pair are solutions to this equation, okay? You should also take those back and substitute them in and check that it works. Again, if you're in an exam, hopefully you should have time to do that. And because you've got to check, you should never need to get one of these wrong, because if those values make both of these equations work, then you've got the right answer. If they don't, you've made a mistake somewhere and you can go back and try and find it. What else do we have to say about that? We have one linear and one quadratic equation, and we've got 2 sets of solutions. Well, that's fine. We've had linear equations where you get 1 solution. We've had quadratic equations where you get 2 solutions. We've got 2 linear simultaneous equations where you have a solution and it looks like x equals this and y equals this. Now we've got 1 linear and 1 quadratic, and we end up with 2 pairs of solutions. For the moment, the answer to that is okay. That's just how life goes. We'll live with that. When we get into section 3.3 and we think about the graphs, it will be obvious why that is going to be true, that we can get 2 pairs of solutions.